Today's topic is analytical geometry. Basic fact, coordinate is a representation of x and y in the form. In this form, we have 2 points, A and B. Distance formula. This is the formula for distance. We use this formula to calculate the distance between any 2 points. Substitution. We take those 2 points. When you're given 2 points, you simply substitute into the formula. You simplify, you get the final answer. The distance between any 2 points, it's measured in units. It could be centimeters and meters and millimeters. The midpoint of a line segment, when you talk about midpoint, we're talking about the central point between any 2 points. It could be A and B. The central point will be in between them. And to get that point, we simply substitute the two coordinates again, x1 plus x2 divided by 2. You'll get the first x coordinate of the midpoint, y1 plus y2. You get the second y coordinate of the midpoint. Gradient of a line segment. Then gradient of a line segment, we know this one is the slope, how steep the line is. If a line is horizontal, flat on the surface, the gradient of that line should be 0. If a line is vertical or it's perpendicular to the surface, the gradient of that line, the line vertical or perpendicular to the surface has no gradient, it's undefined. Then about the gradient shows how steep a line is. As we know, the formula for the gradient is denoted as follows. M is equals to y2 minus y1, x2 minus x1. This is the formula that we use. We need 2 points to calculate the formula, to calculate the gradient. If two lines are parallel to each other, that means they have the same or equal gradient, meaning AB is a line which is parallel to CD, another line. Therefore, M1, MAB is equals to MCD. Parallel lines have equal gradients. Number two, if two lines are perpendicular to each other, meaning they are at an angle of 90 degrees perpendicular, that means that the product of the gradient is equals to 1. Let's say a line AB perpendicular to CD, therefore the gradient of MB times the gradient of CD should give you -1. I think you understand. Say on a straight line, the equation of the straight line is as follows: y minus y1 is equal to m into x minus x1. What you do here, you simply have to calculate the gradient first. After you calculate the gradient, then you will take one coordinate from the ones that you use to calculate the gradient, substitute it at y1 and x1, you leave y and x. Simplified, then you'll get the equation of a straight line. Or alternatively, you can use the traditional equation where we have y is equals to mx plus c. You calculate the gradient, you substitute x and y, then you calculate the value of c. Then you complete your straight line equation. Secondly, the angle between two lines. To calculate the angle between two lines, we use this formula, tan a second function of tan m1 minus a second function of tan m2. Looking at this formula, you can realize or remember that this formula here represents an angle of inclination. We'll talk more about it when we proceed, but for example purposes, to further understanding, let us look at an example of angle of inclination. Let me get my pen ready so that we continue. So with this one, the angle of inclination of the first line, let's say we have the Cartesian plane, then we have a line. Angle of inclination is always the angle between the line and the x-axis. So this will be your first angle. I mean, this will be the second angle, number 2. Then we have another line. So we have two lines. The first line, the second line will have the same angle of inclination, which will be what? Let's say it's beta. So when you subtract the first equation, it will be b. In this case, it will be beta subtracting theta. So when you subtract these two angles, you'll get an angle between these two lines. I think that is where we're talking about. The angle between that two lines, let's just name it alpha so that you can have better understanding. So when you calculate the angle between any two lines, just know how it should be represented. We'll be having the first inclination, second inclination, I mean the angle of inclinations, then you subtract them, you'll get the angle between those two lines. I think you understand. And then secondly, angle of inclination. Let us look more on angle of inclination. Angle of inclination of a line, m is given by what? Tan theta. This is the formula that we use to get angle of inclination. M represent gradient, theta will be the angle of inclination, then tan, that one, it's when we're talking about the inclining. We know it's tan is given by the opposite over adjacent. That's why we get the angle of inclination. To find the angle of inclination, or the angle it takes, the angle of inclination is the angle it makes with the x-axis. We use tan theta. I think I'll explain this one. The angle with a positive gradient, m positive, m greater than 0, has an acute angle of inclination. Then theta have to lie between 0 and 90 degrees. Let's look at an example. Here we are. So for this graph, we have a straight line graph. So the angle of inclination, it is always between the x-axis and the line cutting the x-axis. So it's always between these two. In this case, our gradient is greater than 0. So if our gradient is greater than 0, it simply means the angle of inclination has to be an acute angle. Acute angle is an angle that is less than 90 degrees. Let us look at an example here. They say determine the angle of inclination if the gradient of a line is 1 over 5. We're given the gradient. Solution: the formula for angle of inclination, tan theta is equals to m. The gradient there is 1 over 5. We substitute into the equation. And theta will be given by second function of tan, 1 over 5. Then the angle there will be 11,3. This angle, you can see it's less than 90 degrees. That's why we're saying this is an acute. The angle that is calculated should lie between the x-axis and the, the line itself. Let's look at another example. Angle of inclination. If we calculate the angle of inclination of a line with a negative gradient, m will be less than 0. Therefore, then we add 180 to change the negative angle to an obtuse, where the theta has to lie between 90 degrees and 180. So an example will be this one. If we can see, if the line is moving from the fourth quadrant to the second quadrant, the gradient of that line should be negative or less than 0. Therefore, the angle of inclination has passed 90 degrees. It's in the second quadrant. If you can see, it is in the second quadrant. Therefore, if it is in the second quadrant, it means the theta should be an obtuse angle. So let us look at an example there. An example, determine the angle of inclination if tan or the gradient of a line is negative 0,7. Solution: tan theta is equals to m. Our gradient is negative 0,7. Theta is equal to second function of negative 0,7. The angle that we get, we can see is negative 35.0 degrees. So we are going to add 180 degrees to make it an obtuse. Obtuse angle theta is going to be equal to negative 35 plus 180, we get 145. So why adding, what about this? Where is this angle? Negative 35. To see negative 35, we know when we talk about negative angle, we are going clockwise direction. When we go clockwise direction, it means this will be our angle negative 35. So we add 180 because angles on a straight line, they add up to 180 degrees. So when we add 180, automatically now this will be the angle of reference. It will be our angle of inclination. And remember, angle of inclination lies between the x-axis and the line. So this will be our angle of inclination. X-axis and the line, and that will be our angle of inclination. But we are mostly guided by the gradient. If the gradient is negative, we add 180 degrees. Let's proceed. By Pythagoras, in this case, we'll be looking at a circle. With a circle, we have the radius, x and y. They form a coordinate at this point. This will be the point x and y. So on this point x and y, what is important? We have the center of the circle. We call it the origin. At the center of the circle, there are only two coordinates. It is 0 and always. If the center is centered at the origin or at the center of the Cartesian plane, it's 0 and 0. X will be 0, y will be 0. So furthermore, to get this one, we are going to use Pythagoras to determine the equation of the circle centered at the origin. In this case, by Pythagoras theorem, the radius is r is given by the equation. Before we can calculate the equation, the most important thing, if we are given any point on the circle, we simply substitute x and y here. Then we get the value of r. We are done. Then we get the equation of the circle. Let us look at the first example. Find the equation of the circle given the point negative 4 and 6. We have the circle, we have a point on the circle, is negative 4 and 6. So in order for us to get this one, we refer back solution. The equation of Pythagoras are x squared plus y squared is equals to r squared. Substitution, we substitute x as negative 4 and y as 6. Then as we substitute into this equation, we get r squared as 52. Then this will be the equation of the circle. I think you understand. This will be the equation of the circle. So to verify this equation, you can also substitute. If we substitute a negative 4, you get the value of y. The value of y should be what? 6. Secondly, the equation of the circle centered at AB, which means now this equation or this circle is no longer centered at the origin. Now it's centered at any point on the Cartesian plane. So in this case, the first thing that we are going to do, we are going to talk about the x and the y. From the Cartesian plane, if we move from here to here, this will be our x. And also, if we move from here to here, this will be our point A, value of A. It lies between these two. This will be line A, I mean a vertical line. This will be our A, x value. And then this will be our x value from that point there, x. So what we are going to do, we are going to subtract. We are going to subtract the difference between these two is going to be x minus A. Then the length from this point to this point should be x minus A. Similarly, if we check from the other side, this point to here, from the zero Cartesian plane going upward, we are talking about y, trying to get this value of y here. This point, we get y. Then moving from here to here, we will get what? B. Because remember, if the points are like this, we know A should be x, B should be y. Here should be what? B. So to get the length from this point to this point should be a y minus a b. That one should be x minus a. This one should be a y minus b. I hope you understand. So to get the equation, by using theorem of Pythagoras, the radius will always be the same. It will not change. Therefore, the formula, if you are given this circle of the equation of the circle centered at AB, this should be the new formula that you use. It's x minus a all squared plus y minus b all squared is equals to r squared. This formula, we only use it when we are talking about the circle centered at AB. So let us look at an example. State the center and the radius of the circle with the equation. So here they are looking at three things. We are given this equation. Then this equation, we must write it in a standard form. To write it in a standard form, what are we going to do? We are going to remove this force here. So we are going to divide both sides. Solution, divide by 4 both sides. When you divide by 4, it will cancel out. Those 4 here have been moved. And you can see 16 divided by 4. When we divide both the left-hand side and the right-hand side. This will be the standard form of the equation. Then to get the center, change this one. If it is negative, we just take it as it is, like this one. It's 4, put it here. This one, multiplication to give you a negative. This one should be negative 6. So another way to simplify it, getting the solution, simply take x minus 4, you equate it to 0. To get the coordinates, just take this thing and equate it to 0. Therefore, solve for x. X will be what? X will be 4. Then that is the x coordinate of the turning point. For the y coordinate, you take the y side and you say y plus 6 is equals to 0. Therefore, you simplify. Y should give you what? A negative 6. I think you understand where do we get those coordinates. Positive 4 and negative 6. Therefore, for the radius, you just take r squared and then the square root of r squared should be r. Then the square root of 4 should be what? Should be 2. So to get this 2, remember, radius is always positive. When we use the square root, we know it should be plus or minus, but because a radius is positive, we only take the positive ones only. I hope that one is clear. Let me quickly erase this part and continue. So, and this should be the standard form of the equation. The standard form should be like this. Remember, this is how we got the equation. We must represent it in the standard form first. This is how it should look like when it's in standard form. This will be x minus a all squared plus y plus b all squared is equals to r squared. That is how it should be represented. Then completing the square. So finding the circle and the radius of a circle with an equation. In this case, you'll be given something like this as an example. We have x squared plus y squared plus 6x minus 10y is equals to 2. So you are supposed to get the center of the circle and the radius. So how are we going to do this one? We are going to complete the square. First thing that you do, you collect the x's to one side and you collect the y's to one side. As an example, collect x and y terms, then you put them together. X squared and 6x, you put them together like this. Y squared and negative 10y, you put them together, it's equals to 0. Just swapped and collected the terms that are similar and you place them together. Then the second step, we complete the square. Under completing the square, this is how you're going to do it. You will take the coefficient of x divided by 2 and square it. And then also subtract. You add it and also subtract it. Example, x squared, it's here. 6x is here. Then you take the coefficient of x. It's 6 divided by 2. You also squared. Have the coefficient of x squared. Have the coefficient of x. It's 6 over 2. You square it and also subtract it. Why do you add it and subtract it? We add it and subtract it such that it will cancel out. So we are not changing the equation. When you add it and subtract it, it's just like if you subtract it here, it will take you back to the previous step. This one will cancel this one, we go back to the previous step. Why do we add it? We add it because we want to complete the square. Then after plus, remember, plus 6 over 2 all squared minus 6 over 2 all squared. Secondly, we look at the y side. Y side will be y squared minus 10y plus, then we do the same thing. Coefficient of y. Take the coefficient of y is negative 10, you divide it by 2, also you square it, plus the coefficient of y, you divide it by 2, you square it, and you do the same thing. You plus it and also you minus it, such that we don't change the equation, as I emphasized. It's equals to 2. Then to complete the square, you only focus on this one. If you factorize this one and also factorize this one, it will be in a complete square. When you factorize it, you'll have the following. You'll have x plus 3 all squared, negative 9. Then negative 9 will come from this part. Then a y minus 5 all squared is when you factorize this one. The better way in which you can factorize, after putting them like this, you don't have to worry more about applying the figure out for faster process. To make it faster, simply take x here plus, and then the last term you take the first term x, then the last term you just take the ones in the bracket and you add them, then you put them there. These ones are the ones capable of giving you the sign. 6 divided by 2 is 3 all squared, then you're done. Then you solve this one, it will be negative 9. Coming this side, it's y. Then negative 5 divided by 2, it's 5 all squared. Then negative into this one, it will give you negative 25. Therefore, when you're done with this one, what is left is for you to take this term to the other side. We have negative 5 and negative 10. When you take them to the other side, taking constant to the right hand side, you can see it was negative 9 and negative 25. When they come, they add with 2, they'll give you 26. Then in this case, we have our equation in a standard form. If our equation is in a standard form, then we have the following. The coordinate of the center, we know it's a and b. Then r, there it's what? It's r squared, it's 36. So to get the final answer, the coordinate of the center should be negative 3 and 5, as you can see. So how do you get these values? As I indicated, say x plus 3 is equated to 0. Then you solve for x, it will be negative 3. Y minus 5 is equals to 0. You solve for y, then it will be what? 5. Then to get the radius is simply the square root of 36. It will give you what? 6. I hope you understand that part. Then secondly, let's go and look at another example. The example here, it says find the equation of the circle with the center negative 5 and 2 passing through a point 6 and 8. So one of the most important thing, we having two things. The center here is what? Negative 5 and 2, the center of the circle. Then a point, it's 6 and 8. Therefore, the equation that we are going to use is x minus a all squared plus y minus b all squared is equals to r squared. This is the general equation for the circle not centered at the origin, or it is centered at AB. So firstly, we substitute the coordinate of the center. It is a negative 5 and 2. Remember from the question, we substitute AB, negative 5 and 2. So what is important? What about the sign? You don't have to worry more about the sign. Just substitute the values as they are from the equation. Here we had negative 5. So it's going to be negative by negative. They give us what? Positive. Here it's 2. We simply substitute by what? By 2 and get that value. So the negative here won't change. Here the negative will change because negative by negative will give us what? A positive. You don't have to worry about the sign so much. You just substitute into the equation. Then the sign will take care themselves. Secondly, we substitute a point. A point, we have x as 6 and y as 8. So here, x is here, y is here. We substitute those two. Then when we substitute x and y, we see 5 plus 6 plus 5, it gives us 11. Then 8 minus 2, it gives us 6. Therefore, the value of r squared there will be 157. So that is our r squared, not radius, but r squared. So The equation, remember they required us to get the equation. The equation is just to write this one from the standard form. So we substituted the center of the circle, the radius, I mean r squared, then this will be in the equation of the circle. I think you can also see that one. So we were given 2 points, the center and a point on the circumference. Then we can get the equation of the circle. Let us go and look at the equation of a tan at a point on the circle. When we talk about a tan or tangent to a point, it means we are having a circle, and then on that circle, a line that is touching the circle once, the circumference of the circle once, it will be tangent to that circle. So an example is this one. We have a circle, a line touching the circle at a point, it will be tangent to the circle. So when we talk about tangent, we're saying the tangent is always perpendicular to the radius, meaning they're at an angle of what? Of 90 degrees. Between the line and the radius, they should be at an angle of 90 degrees. And remember, at the beginning, we talked about gradients. We said if we are having two lines that are perpendicular or are tangent to each other, we can simply say the product of these two lines should give us what? -1. So if we can get the gradient of this one, we can also get the gradient of that other line without using the equation of the gradient, by just simply multiplying the perpendicular gradient. So method. To get the equation in a standard form, you firstly need to get the equation in a standard form in order to find the center. So you must be using the equation of the circle. You must get the center of the circle by writing the equation in a standard form, completing the square, simplifying it, and then getting it in a standard form. Secondly, find the gradient of the radius. To get the gradient of the radius, you must be given 2 points. Point number 1, you calculate the center of that circle. And number 2, the line perpendicular, which means the tangent. They must give you a point where the straight line or tangent to the circle is touching the circle. That point, you're going to use it to calculate your gradient. Thirdly, the line is perpendicular to the radius. So if they're perpendicular, you can also calculate the gradient. We use the perpendicular gradient and a point on the circumference to write down the equation of the tangent. I hope this is clear. Let us look at an example. Find the equation of the tangent to the circle. We have the equation of the circle is this one. And then we have a point where the straight line is touching the circle. So it is tangent to the circle. So the first thing that we said we have to do what? Write the equation of the circle in a standard form. So to write it, solution, the equation of the circle is there. We now simplify it, completing the square. Remember, now the other method is not here. I mean, the other step is missing. I think you can understand what we did. What did we do? Take 1x here, then we take the coefficient of x, we divide it by 2, and we square it, and then we simplify. This will be -1 all squared. Second part, this one, where does it come from? We say the coefficient of x is -2, we divide by 2, it will give us what? -1. Then we square it. I hope you understand. This one is the one for positive, this one is the one for negative. For an example, to do this one, you simply say minus into -1 and -2. The coefficient of x is -2 there, divided by 2 and squared, plus coefficient of x is -2 divided by 2 all squared. I think you still remember this part. So this part is the one that we used in the bracket. This part is the one that is remaining outside. So this one, unfortunately, I'm sorry, here it should be positive, and then the other one should be negative. So it's could be more clear. This one should be negative. So this one, -2 divided by 2, it will give us what? -1 squared, it will be positive. But when we multiply it by negative, it will give us a -1. This is the one that we are having here. Then this one, it will be positive. Negative 2 divided by 2 is going to be a negative 1. Square it, it will be positive. Multiplying by this positive, it will be positive. It should be this one that we are having here. So by this one, because we are factorizing, it should be x minus 1 all squared. I hope you understand that part. Therefore, and the y side, we do the same. We take y here. Then the coefficient of y is what is 4. We take 4, we divide it by 2 and square it. It will give us what? 4. Then we do the same as we did here with a negative 4. And then we say negative 4 divided by 2 is going to give us negative 2. When we square it, it's going to give us a negative 4. Then second step, factorize it, taking the constant terms to the other side. Negative will be positive and negative 4 will be another positive. So they add up to 10. And this is in standard form. I hope you understand. So the equation of the circle is this one. We have r squared, the coordinates of the center of the circle. Then we simplify. The center is given by 1 and negative 2. This one, as we take this equated to 0, solve for x, it will give you what? 1. Y plus 2, you equate it to 0, you solve y, it will give you negative 2. That will be the coordinate of the center. Secondly, the radius will be given by the following. The radius, the square root of this one, you will get the square root of 10. Secondly, we get the gradient of the radius. The gradient of the radius, we have 2 points. The center is the point and the other point that they're making contact on the circumference. Substitute them here, we get the gradient of 1 over and negative 1 over 3. That will be the gradient. The gradient will be the one. If we are having a circle, point of contact, sorry, we are having a circle, the center of the circle, and a line touching the circle at one point. So to get the radius, to get the gradient of the radius, we use the point of the radius and the point where they are making contact, the circle and the straight line. So that's why we substitute these values to get a 1 over negative 3 or negative 1 over 3. Then secondly, the gradient of the tangent is 3. So if we say to get the gradient of the tangent, we're saying m1 multiplied by m2, it should give us what? Negative 1. So we substitute this one here. We make m2 the subject of the formula. We equate solve for m2, then we find m2 as what? As 3. I hope you understand. So this one is perpendicular gradients. When we multiply these two, they should give us what? Negative 1. Then the equation of the straight line, we use the formula for straight line and we substitute coordinate. When we substitute, we cannot substitute the center here. We cannot substitute the coordinate of the center. Why? Because the center, it is not on this line. The center is not on the straight line. So we are going to substitute a point. It's negative, it's 2 and 1. So this is the point on negative 1, I'm sorry. It is 2 and negative 1. This is the point that we are going to substitute. Y minus y1. Y1 is what? Is negative 1. So negative and negative will give us positive 1. The gradient there is 3. And then into x. And then x1 there, it will be what? It will be 2. Then, okay, it should be also negative 2. I'm sorry. Negative 2 and negative 1. Then we simplify. This will be the equation of the tangent. So it is the equation of a straight line that is touching the circle at one point. Let us look at finding the length of a tangent from an external point. So to finding the length of a tangent from an external point, we are given this shape. We want to know the length from either B and A. And also we know the equation of the circle. So when we are given the situation, let us go to method. The first thing that you do, you find the center and the radius of the circle. That is the first thing that you do. You find the center and the radius of the circle. Number two, you find the distance between the center and the external point. Number three, you use Pythagoras to find the length of the tangent AOB right angle. Then that will be your right angle triangle. Let's go back and see what we do. Just try to mention those points. You start by getting the coordinates of the center of the circle by using the equation. Then you get the length of the radius. After getting the length of the radius, then you know the side. Then you can also use these 2 points to calculate the other side, BO. Then that last point will be remaining. If you know these two sides, you can use Pythagoras to get the other side. I hope it makes sense. Then find the length of the tangent drawn from the point -3 and 1 on the circle. This is the equation of the circle. We are looking for the length of the tangent drawn from the point -3 and 1. So here we are having the equation solution. The equation of the circle is given there. First thing we do, we find the center of the equation is 3 and -1. They're given. Then the radius is what? It's 2. So once you get the radius, you know you get the length from the center to any point on the circumference. Then secondly, the distance from the center to a point, you're going to use Pythagoras, where we simply substitute. This side, it will be the equation. This one is just simply the equation of the distance formula. I think you remember that d is equals to the square root of x1, x2 minus x1 plus y2 minus y1 all squared. Then this is the distance we get it calculated in what? In units. So this will be the length from one side. Secondly, the length of the tangent. The length of the tangent would be x. So this should be a 90 degrees. This one is the radius. This is that point that was given. This is the center we get. So this one you are simply going to use Pythagoras. When you use Pythagoras, x is equals to the square root of, then this will be the square root of 40, then that will be r. This will be y. I think you understand. Therefore, the square root of 36 is what? A 6 unit, which means the length of the radius, length of the tangent there, it should be a 6 unit. I hope you understand. Then at the tangential circle external. So in this case, we'll be having two circles. And for example, the first circle and the second circle centered at A, and then the second one is centered at B. So the length of the radius in this case will be A. The length of the radius this side will be B. So the tangential, if the length of AB is equals to the sum of the radius A and also B, therefore these two circles are tangential, meaning they have a tangent. They touch at only one point. The length of the radius, it's radius number 1 plus radius number 2, it's A plus B. Secondly, if we are having the coordinates, AB should be equal to A plus B. The length AB should also equals to the sum of the two radiuses. I think you understand. Then when we go to a tangential external is still making the same application. We're having two circles that are touching at one point. If they're touching at one point in this scenario, we are going to say the length of AB, the distance from AB should also be equal to the difference between the radiuses. The first radius, it will be from A, it will be from this side to here. A will be from, let me just try to indicate, it will be from here to here. And then B, the radius will be from here to here. So when you subtract these two, they should also give you the length. That's why we say AB is equals to A minus B. Then these two circles are tangential internally. The other one is externally. Then to show that two given circles are tangential, you need the following. You're going to use the two circles. We have circle number 1 and circle number 2. And then secondly, equation number 1, we simplify it to get the center of the circles and the radius, the square of the radius. Number 2, the circle center is -1 and 3. The radius is what? It's 1. The square root of 1 is always 1. Secondly, the second equation, we simplify it and get the center of the circle and the radius. It is 2 and 3, and the radius is what? It's a 2. Then secondly, when we proceed to show that two given circles are tangential, the distance between the circles are given as follows. Number 1, you calculate the length, the distance between the two circles. In this case, it is 3 units. Then the sum of the radii, it will be 2 plus 1, then they give us 3.